Hello, hello, good morning. Welcome to the AI tooling session. We have lots of tools to go through today, and come on in, and we should get started. Can I ask you to put the slide on? Huh? It's not. Okay. Thank you. Right. Welcome to the AI tooling for DestinE session. This is co-shared by me, Tiago Quintino, and Miruna Stoichescu from EUMETSAT. AI is changing the world, and tools come with it, and tools give us control over AI. And so I hope that this is a session to give you the tools to do what you need to do for DestinE and maybe beyond. In this session, we are going to focus on practical AI enabling capabilities, tools, services, platforms, workflows, a little bit of infrastructure to help users access data, experiment with AI methods, operationalize workflows, and integrate AI components. There will be first 3 presentations from ESA, then 2 from ECMLF, and then 2 from EUMETSAT, and then hopefully we'll have some time for Q&A. Could we display the Slido QR codes so that you can start asking these questions as the session is going? And before we start. So that's the Slido QR codes. Take a snap of that, ask as many questions as you would like as the session is going, and at the end, we will try to answer them, okay? So let's get started. My colleague from Jülich, please introduce yourself.
Yeah, hello everyone. My name is Jens René Göbbert. I'm here with my colleague from the Jülich Supercomputing Center, and would like to show what we are trying to make possible for the DestinE platform, coupling HPC to DestinE platform in the Hippo project. So you can see here desk service integration with HPC resources. And just to start, what is Jülich? Just some kind of numbers, or at least a rough view. Jülich Supercomputing Center, located near Cologne. I would say currently most prominent system is Jupyter, the exascale system. And when we say a lot of compute, then we talk about really a high number of GPUs, so 6,000 nodes, roughly 24,000 Grace Hopper 200. So if that tells you anything, at least I just want to make the point. HPC, number crunching, that's coupling to DestinE is, I think it's a valid point to make possible. And therefore, in the Hippo project, we are focusing on this topic, making access, usage of HPC in DestinE through coupling to the HPC system, exploring different scenarios for fair usage. Open source, of course, is priority, and also making that possible through orchestration, workflow orchestration. So we are using Apache Airflow as the framework underneath. I've seen that there were quite some other projects already building with Airflow. For us, it's a good starting point to add the HPC components. So an interface which is, say, less complicated than SSH directly on the system, but still an interface which is that kind of full features that it's more for the, the expert usage of workflow orchestration. And in this interface, we are coupling here, you see it on the right side, we are coupling the component Apache Airflow running on the DestinE platform to the HPC here on the right side at the bottom through some component called Unicore. So from the kind of user perspective, one can send now tasks to the cloud or to the HPC with not much of a change. And yeah, this has been deployed to the DestinE platform. Sure, you can imagine a few things underneath, but we are demonstrating that at the demo booth, how to send from the DestinE platform workflows to HPC. And yeah, looking for your use cases, looking for your interest, of course. We came from the technical perspective, setting that up, and are now making it more and more from the usability point of view. So any kind of feedback is very valuable. For us, we are here, two of the team. So my name is Jens Henrik, and Christian is also here. So if you like, and we would love to see you at the booth at 10:30 to 1 p.m. That's all from my side.
Thank you very much.
So hello everyone, I am Najla Said, I am Cloud Architect of the DestinE platform from Serco, and I want to speak today about a new service that will come on the platform that we call DestinE AI Hub. The name speaks for it, so we would like to build a hub for the DestinE users where they can share their knowledge and collaborate on AI models. So this service is done in collaboration with our Gael colleagues, and we are working on two main objectives, I would say. The first one is to provide to the DestinE user a registry of models, datasets, and in general artifacts to which they can collaborate. So they can share their own model and datasets, and they can work together on this. Clearly, they will have also access to some computing access in order to be able to work and collaborate on these models. The other part of the service is focused on provide to the users endpoint to run pre-trained model and to get easily model output. And this is what we provided here with the demonstrator. The demonstrator, you can try it by looking at the QR code. And we implemented an AI endpoint for the AIFS model from ECMWF. So what you will find while accessing the demonstrator is a web interface in which input data are already selected from the most recent, and you can select the lead time for your prediction, and by running your prediction, you are available to get your output. Then, directly on this user interface, you are able to select the variable that you want to plot and have an overview of the variable that you want to explore. Or you can, thanks to our colleagues in Gael, you can take the output of this run and explore it in a more advanced and with more possibility inside the Delta Twin service. So you have a link to a component in the Delta Twin service that can allow you to make, let's say, in deeper analysis of this kind of results. So this service will soon be available on the platform, and we are really open to suggestion also, for example, about what services you would like to have available as pre-trained services and endpoint to be used. So we selected, we thought to some most used model, but we are really eager to receive also your suggestion. So thank you.
everyone, I'm Benoît Pironnet, Product Manager at Gale System. Today, in this 5-minute presentation, I will give you a quick introduction to Delta Twin, a service to deploy and run AI model in the DestinE ecosystem. We'll go through 3 use cases in Delta Twin in the context of AI model, a machine learning model, a weather forecasting model, and a Sentinel-2 Earth observation data pipeline. And then I will share with you some perspective we have for the future. So Delta Twin is a collaborative environment where you can configure, deploy, and run and share multi-scale model in one place on cloud infrastructure without managing servers yourself. Concretely, your AI model is packaging as a block inside a Docker image, making it portable and reusable. Any data or parameter it requires are stored separately as resource in Delta Twin storage and reference at runtime. You can then connect these blocks into a workflow, execute it, and share the results. So our first example is a machine learning downscaling model for urban heat island analysis developed by Collab Atlantic. It takes climate data and produces city-scale temperature maps, exactly what urban planners need. The model runs on Kubernetes and can be executed automatically on schedule with no infrastructure management from the user. Our second example is AIFS ECMWF fully data-driven weather forecasting model. What interesting is here is the interoperability. AIFS models is hosted in DayHub, previously present by Najla, and Delta Twin can call it directly as part of a workflow. Delta Twin does not need to host every model. Instead, it can integrate external services through standard interface, which is one of its key design principles. In this example, the central blocks predict call DayHub services. Our third example is AI Assign to Core, an AI pipeline developed by Sébastien Teto from ISA for generating Sentinel-2 level 2A products. It can run either on GPU or CPU depending on the available resource, and it's fully open source on GitHub. On the left part of this slide, you can see the initial Sentinel-2 image, the generated image from the model, and a reference image. Below, you have a comparison curve. Would you bring your own model? You can package it and share it with the community. Documentation, tutorial, and starter kit are available. You can also submit features requests through DestinE public roadmap. So in the future, we plan to provide more AI model out of the box, including AIFS, Terramine, and GraphCast, all chainable as building blocks within a complex workflows. We are also expanding GPU support to execute more intensive data pipeline. So that concludes my presentation. Come and meet us at demonstration table 3 at 4 p.m. Thank you very much for your attention.
Awesome. Hi, I'm Harrison Cook. I'm a research software engineer at ECMWF. I'm going to talk a bit about Anemoy. Some of our colleagues here from ESA have, talked about the AIFS. Anemoy is the tool that builds it, and that was talked about this morning as well by my colleague Sarah. So Anemoy is the machine learning weather and climate forecasting tool, the framework that has been developed at ECMWF alongside our member states, the European Meteorological and Hydrological Services. So it's that toolkit to cover everything from dataset preparation, to go end to end, from dataset to running the model to inference as well. It's fully open source, it's available on GitHub, and it's been open source pretty much since we started the collaboration with our member states. And Anemoy as well is not just for ECMWF, it's not just for the global medium range weather forecasting problem. Our goal is to encapsulate everything that is needed for the forecasting problem, whether it be that medium range for us, whether it be local, or particularly regional for some of our member states, or even some applications on the climate space there as well. One of the things that we think is quite exciting is this tool that we use in operations is the exact same one that is open source. Anemoy Inference is exactly what we run 4 times a day, every day, to produce our AIFS. So it is built with the community, and it is built out in the open. It has really started out as to become quite a collaboration across a lot of the member states of Europe. And this is just some examples of them here. And this is not just open to the meteorological and hydrological services. It is also open to universities, to private industry, and it is, freely available on GitHub there. So if we go into a bit more technical, a bit more of the actual packages that make up Anemoy, it has been made up of various components, multiple packages, but they all form one, we hope, cohesive pipeline, one cohesive experience to simplify what it takes to produce a machine learning weather forecasting model, to train that checkpoint that you're going to use in operations. So starting from the left, we have Anemoy datasets. That's what takes in those raw, messy, sometimes complicated GRIB files, NetCDF. It allows for access from Mars, from the CDS, and from other data sources there as well. And within the Anemoy ecosystem, on our catalog, we manage about 870 datasets, approaching about 1 petabyte worth of data. And that is something that we then transfer and we move across the Euro HPCs and our various compute platforms to make it simple and make it reproducible of the training of the models themselves. If we go then towards the actual model, we have what we like to call Anemoy Core. It is made up of 3 sub-packages in of itself. And we're not very creative with our names. You should be able to get the picture from their names. So we have training, models, and graphs. Graphs is the AIFS, and a few of its other components are built on graph neural networks after some of the GraphCast work from Google. And as well, then we have the models package, which then takes those graphs, those graph neural networks, and stitches them together into that machine learning model. So that's the layers, that's what implements the graph transformers that we use for the AIFS. And then, of course, you actually need to train the model. You need to be able to orchestrate bringing that data into the GPUs, feeding those batches through, and we use Anemoy training to do that. And it's designed to scale up to the larger HPCs to allow multi-node training and handle that full training pipeline. From there, once you have your checkpoint, you actually want to do something with it. So we have Anemoy Inference, which then handles itself, getting the initial conditions, getting the real-time analysis from the IFS, for example, for the AIFS, preparing it, making it ready, getting into the right format, and then actually running the model. And it is all those packages that make up all the different models. They all use the exact same pipelining, the exact same packages, with slightly different configurations. And that hopefully makes it quite easy to extend and to use and to adapt it to particular use cases that you might have. And this is already running in real time. This is already running for ECMWF, as I said, 4 times a day. We have just released our AIFS 2.0 as of May 12th. And of course, now DWD is running it in operations, and we have various other member states who are pushing forwards on that pre-operational stage or very deep into their research phases as well. And then within that, both, just the models that are for medium range or for the forecasting, we're working on including some things of the climate emulators that was talked about earlier, and as well some of our observation prediction sort of systems, the AI DOP framework as well. And I like to think, people are actually using it. I had a look at these numbers before making this presentation. They all roughly came out to 10, which is nice. We have quite a number of downloads from PyPy. We have quite a number of contributing organizations, and it is appearing in peer-reviewed publications. It is what underpins the AIFS, those papers you've read. It is what underpins the Breeze model from Met Norway, the AICON from DWD. There we go. So that's Anemoy, and that's how we use it within ECMWF and at our member states. But how is Anemoy used in Destination Earth? We saw earlier as well that it is being used in a few of the components of the digital twin. We're exploring things of the climate emulator, and that is built on top of Anemoy. And we're exploring as well integration into the digital twin engine. You saw some components there of running the AIFS. That is using Anemoy. That is using Anemoy Inference. So we're both using the digital twin outputs. We're taking those and making them AI ready with Anemoy datasets. And it is built upon that same software that builds the digital twins and under that infrastructure. So it's the same compute platforms, it's the same data, it's the same archives, it's the same data bridges there as well. So just for concrete use examples, we have the climate emulators from Predictia, and that is showing quite good stability for those climate scales, and it is built on top of Anemoy. We have the uncertainty quantification of taking those and expanding the ensemble member generation. Once again, I'm sounding like a bit of a broken record. It is built on top of Anemoy, and it is what is enabling these more rapid, more quick iterations, getting from an idea to a checkpoint to something where you can do research upon it. And it is, of course, built for the machines that train it. So Anemoy needs, and to train a machine learning model needs a big HPC. While inference is cheap, training is not. So it is built for the Euro HPCs, and we're capitalizing on the Euro HPC's computes, and it is simply perfect for it. So, you know, it supports vast parallelism. It is fully compliant with the HPC conventions. We're exploring multi-site training and moving data sets between them. And, you know, what runs on the Euro HPCs for operations or on for the DestinE platform, again, is built for Anemoy. Slides. There we go. And yeah, so the HPC, you know, we're exploring taking the digital twin data and preparing those for the AI ready, making them ready for training, and then using the AI factories to train and refine and to create these checkpoints at scale, to go to super high resolutions where you need to parallelize over many nodes, and Euro HPC is the perfect place to run our training. So for practice, you know, my colleague Sarah showed us this morning, we're building the Earth system modeling digital twin within the destination Earth, combining the different components, putting in the atmosphere, the waves, the sea ice, and many more, and that is all part of Anemoy. And then just some fancy GIFs, why my presentation is about 100 megabytes. We have a lot of different groups that are exploring this for different sort of practice, different local area models, different components, and different applications. How am I on time? Sweet, I go nice and fast. So if you wanted to get involved, if you wanted to actually use Anemoy yourself, yeah, you've got the applications on the Destination Earth platform, and that is really cool. It really makes it quite low code, makes it quite easy to use. Tiago will talk as well about one of our projects to try to simplify it and try to make it easier for people to use the forecast in a box. But as well, you know, AIFS is openly available. It's open weights on Hugging Face. The code is open, and it should be simple enough to go from how about I run a forecast to actually getting the outputs and then having to deal with those many gigabyte files and trying to evaluate them. So yeah, the AIFS is available on Hugging Face. On the same day that we went into operations with the AIFS2 and the AIFS1, we're very proud that we put them available on Hugging Face. As soon as the first products went out, so we turned on the public switch for Hugging Face. You can take our exact weights that we run in operations 4 times a day. It's probably like the SHA is identical with what we run in operations, and you can run it yourself. So you can download our initial conditions from open data and run the model, and it's all there published under a freely available license. And as well, if you actually cared about, if you wanted to actually start running it, that font is a bit small, sorry about that. It should be hopefully Anemoy inference, and the ecosystem makes it easy to run. It's hopefully a simple install. It's simple, where is my checkpoint, where is my data, run, and then you get your outputs from there. So if you want to get involved, you can try the forecasts. You can try to run a forecast from Hugging Face. The code is available. The documentation is there and open for you to explore. And if you're interested and you want to get involved, you know, get involved on GitHub, open an issue, start chatting to us. We're excited to see what people can do with this tool and how we can enable quick research for AI-based weather forecasting models and Earth system models as well. Thanks.
That's great. All our speakers are keeping to time. Okay, I'll talk to you about now about forecast in a box. There are some times, yesterday we had a very inspirational talk from our colleague Martin van Halst, head of KNMI, and he was talking about imagining. Sometimes we dare to imagine things that we could never think before. And a few years ago, we dared to imagine forecast in a box. The idea of putting everything the ECMLF does on a big supercomputer fit in a box and allow people and users to run them directly. And that's what we have now, and we are very happy to be presenting, and it's coming and will be released into the public very soon. This is a project in collaboration with the Norwegian Meteorological Institute. Is co-funded by Destination Earth. That is part, of course, mostly ECMLF core knowledge, but a great part also funded from DestinE. And it's about the realization that actually running forecast models, as we heard already many times today, has become very, very lightweight due to the usage of a technology we call AI, but truly is grounded on being able to use GPUs to the max of their capabilities. And right now, we take few minutes to run an operational AI forecasting system, and we use 1 or 2 GPUs. So if you have access to this sort of resources, you should be able to run it yourself too. And that's what we are trying to do. So from a supercomputer to super convenient. It's a bit cheesy title, but let's go with that. Imagine a future where you have a little workstation which just has one GPU inside, but you are able to download ECMWF's initial conditions, and you are able to run it there, and it only makes the products that you need, right? You can tailor it, you can improve on it. So the idea is that we don't ship the data to you. This is a different model. We ship the model to you, the forecasting pipeline. And the paradigm really is one of, instead of sending huge amount of data, we send you the knowledge to produce that data, okay? Ship it nicely and put it in what we call a box. This is not a physical box. We'll get to that. So when you run a forecasting system, you have more or less very high level, 4 blocks. One, you need an initialization. Second, you need a model to run. Then you need a product generation. And then you disseminate those products. This is what if you think about the creation, the model run, plus the product generation, that's a forecast, okay? So that is what we think about the forecast in a box. The capability of doing, we don't call it model in a box because we want the processing too. We don't want you to just have the raw data. You should be able to make your own products. So this is based on the technologies we already heard many times today, Anemoy, and one that you will hear later this afternoon. There's a training session. Please pick in. It's called EarthKit, and it's a framework to process Earth system data. And the two of them together, they play very nicely. One delivers the data, the other one processes, and it's very easy to install, hardware agnostic. The idea is that you should be able to run it on your hardware. It's an intuitive UI that you can fully configure this workflow, leverages the performance of all the Anemoy models, and has all the production-grade product pipelines that ECMWF runs. So we literally put in the box what we run in our data centers to produce our products. Is no different. So as I said, it's not a physical box. It's a virtual box that we are packaging and giving it to you. And the interesting thing is that this is enabling things we didn't think about, we didn't think possible before. You can see here a picture of the head of the Met Norway presenting the head of the Malawi Meteorological Service a Mac Mini because it has a GPU inside, to be able to run this software. And we are working very closely with them to be able to give them the capability and the sovereignty of being able to run their own forecasting systems based on our models and our pipelines, and they will make their own products, the products that they are interested on. This is just the beginning. This was the first project that kick-started this whole development. And we are now going to, I will later show you, we are now going to work with more sub-Saharan African regions in order to provide this in a wider context. So Forecasting Box in the end is like a front end that allows you to configure the forecasting system, and a back end that knows how to translate what you requested into an execution graph that then executes in the available hardware, the available resources. So it inspects the resources. If you have just one GPU, it will ensure that it just uses one GPU. And if you have like a full HPC behind, it will run on an HPC. So it's up to you to give it the resources. So that's the UI there. You can choose configurations, and you can have these blocks where one is the model, the other one is the processing, interpolation, mapping, and so on. You can have graphical products, you can have data products, you can export to ZAR, you can export to NetCDF, and all this is integratable even with weather forecasting systems via the web map services. So if you create graphical products, then you can see them in a web maps via web map services. So the forecasting box has these main components. They are color-coded, so they are easy to kind of group. We have models, so we have a plugin system where you can bring your model. So if you develop a model with Anemoy and you end up with a model that runs in Anemoy inference, that will be this blue block, and you'll be able to drop in and run your model in the box. The red is plugins for products, so you can generate and compute your own products. You can bring in your own plugins. And you have data export plugins, so we will, of course, do Grib, NetCDF, ZAR, but if you are interested in your own format, say JSON or whatever, you can bring your own plugin for data export. And then we have plugins for plotting. For example, you can do things like maps, meteograms, time series, and so on. If you have your own, you can extend it too. And what we do is that we take all that and all those connections and we transform it into a graph, a direct acyclic graph, to be more precise. And then we have an engine that knows how to take this and run it on the background. Of course, supports many different formats. And what makes this a little bit more challenging than just a standard, say, software project is that we are taking the burden of the deployment of this software. What do I mean by that? Is that we are really testing that this can run in many different configurations. You can run it on your laptop. I'm serious. You can run it in your laptop. Of course, it will be depending on what GPU you have in your laptop. You can run it on a cloud service, and we plan to the end of this year to integrate it with a Destination Earth service platform, and you'll be able to run it on the Destination service platform with the browser being on your side and the engine on the platform side. You can also deploy it on an HPC. This is how we run it at home. We have a gateway, and then the HPC has the execution engine, EarthKit plus Anemoy. So, as I said, we have many ongoing projects. We are starting now a new project called African Regional Centers for Excellence Program, ARC-X, where ECMWF is one of the providers or one of the partners, and we will bring the forecast in a box to the different regional centers in sub-Saharan Africa and give them, and first of all, listen to their requirements, what do they need, how if the box is fitting their needs, and we will iterate and continue to develop for what they need, and then give them really the capabilities of running their own forecasts rather than being dependent on the beneficiaries in the rest of the world. So that's it for me. These are QR codes if you're interested in EarthKit, Forecast in a Box, and Anemoy. This is all open software. What I mean by that, it's only open to run and open source. We are also doing this in open development. So if you are interested to interact, collaborate with us, co-design, co-develop, get in touch and provide pull requests, provide issues, start a dialogue with us, and we will happily listen to what you have to propose and integrate it with us in all those three platforms. Thank you very much.
So, hi everyone, my name is Miruna Stoicescu, I work at EUMETSAT, and now I'm going to present to you the service offering that we have on Destination Earth Data Lake for AI developments. First, a few words like the motivation, why do the AI developments on the data lake, then the current status of our edge services, later on the actual tools and services that we offer, an example of AI/ML application that has been developed on the data lake, and just a few words about how we envision users developing their applications there. So why do AI developments on the data lake? Well, the motivation is that we have a wealth of data in the DestinE data portfolio. The data lake is the component that provides access to this wealth of data as well as near data processing capabilities. So it's only natural that we also want to empower users to do developments in machine learning to gain insights from this data. There are, of course, challenges. So there are challenges related to the data itself that is very heterogeneous and has a very large volume. There are challenges related to the infrastructure, and as well related to the development of the machine learning pipelines themselves. You've probably seen this slide before. So this is the current service offering that we have. So we have at the top the harmonized data access. So this is a stack-based API that offers to users access to all the DestinE data portfolios. So these are the digital twin outputs, the user-generated data, as well as federated data from multiple sources. And then in the second, so in the lower part of the slide, you can see the what we call the near data processing services. So these are services ranging from platform as a service, software as a service, function as a service. So depending on the user needs and wishes, we can offer different kind of capabilities for them to develop their applications. Now, what are we bringing to this service offering? So first of all, we bring what we call DeFair. So this stands for Destination Earth Framework for Preparing AI-Ready Data. So this is a plugin-based framework. It is highly modular. It allows users to define their pipelines either in YAML or directly using a Python API. I hope this works, yeah. So it provides a unified Python API to we start with the EUMETSAT satellite data from the data portfolio, which is already very challenging because we have multiple programs, multiple instruments, different processing levels, so different formats as well. So it's not easy, let's put it like this. So DeFair can read data either from the local file storage or from S3 or from the harmonized data access API itself. Then in the second column, you can see, actually, let's see if this works. Yeah, it works. Yeah, so here you can see just examples of the missions and instruments that we support so far. Then users can do the kind of operations that they need for pre-processing the data. So this can be region of interest extraction, it can be spatial filtering, temporal filtering, reprojections, that's a very challenging one. And then they can export to the output formats of their choice for their applications. So, and we know everybody is a big fan of ZAR. So that's one headache removed, basically, to go from these legacy formats to ZAR. Yeah. And here, yeah, I think it's quite small. So you can see just an example of a pipeline definition. There's actually going to be a training this afternoon. So there are 2 different sessions for DeFair. So yeah, please join us if you want to hear more about it. Here you can see some nice visualizations of what you can do with DeFair. So you start from the original native geostationary view, so how the MSG looks at the Earth. Then you can actually regrid this to your target grid that works for your application. And it's very important to mention that this is a modular thing. It's incremental development, so we keep adding support for new product types and new operations. And we're actually going to open the first version to end users pretty soon, so in June, July timeframe. And then we are open to also collect feedback from your side. So what works well for you, what doesn't work well, what other products you would like to see supported, and so on and so forth. The next important development that we have is the managed MLOps platform. So this is for supporting users in doing the end-to-end ML lifecycle. So this is data ingestion, data preprocessing, training, deployment, and monitoring. It's again a modular solution. So we have 3 different components inside: managed Kubeflow for scalable machine learning pipelines, managed MLflow, and managed Airflow. Airflow has already been mentioned before. Users are able to use one or multiple services. There's no constraint for that. And the first one that is coming up, whoops, no, not this one. Yeah, so the first one that is going to be offered to the users is the managed Kubeflow, for which we have just completed the acceptance. So pretty soon we're going to open it. Yeah, it's important to say, so all this cloud native is managed, so it removes the headache from users to have to set up their own Kubernetes clusters, for example. The next development is what we call the DestinE Data Lake Cube. So this provides to users an easy way to access data cubes for diverse Earth observation and meteorological products. So we start with MSG, MTG, PS, Sentinel-3 Marine, but we will have more data sets coming up. So it's both operational feed and reprocessed data. So in EUMETSAT, we have the recommendation that if you do machine learning with our data, you should rather use the reprocessed data if this is available. The data sets are already on a HillPix grid. They are offered in ZAR. The development is actually based on the recommendations from the OGC GeoDataCube Standards Working Group. It's built around open standards such as Stack, OpenEO, and ZAR. It's a multi-site concept, so it can be deployed on the different sites of the DestinE data lake. If you remember, it's a geographically distributed system. So the idea is to be able to deploy different instances in proximity to the source data. We start actually with one instance deployed on the DestinE data lake EUMETSAT bridge because we focus in the beginning on the EUMETSAT data. And as future work, we are going to work on a streaming API as well as explore virtual ZAR, so providing to user, so comparing, let's say, performance between storing the data directly in ZAR and offering a virtual ZAR layer on top of the, let's say, legacy formats. The minimal viable product is about to be delivered, and we plan to open this to end users in Q3. It actually has two components, so two streams of work, so to say. So there's the data cube generation, which can also be instantiated by the users in their own processing environment, and the GeoDataCube API that actually serves the data and also allows users to do some near data processing. It's integrated into the existing DEDL ecosystem in the sense that it's already making use of the services. So it's based on the islet compute, it's using islet storage, it's using the harmonized data access for getting access to the original native data, and it's also using Defer in the data cube generation part. Another development that was completed a while ago is what we call the AI widgets or AI assistant. It's actually a chatbot on the DestinE, on the DEDL web portal. And this has the role to support users in getting started with our services because we have a lot of documentation on Read the Docs. We have a lot of Jupyter notebooks explaining to users how to work with HDA, how to access the different data sets and so on. And we also have a lot of Jupyter notebooks actually sitting on GitHub, and it can be a bit daunting for users who just come the first time to our services. Here you can see a preview, but you can also play with it by yourselves on the portal. And I would also like to mention that we have been doing experiments with exposing an MCP server with our HDA, so this would empower users to do natural language queries, for example, to explore the different data offerings we have, but also go inside the data set, search for relevant products. And we plan to extend this proof of concept with more tools exposing the MCP server, so going towards actually downloading the data and plotting it. We have run 3 different contracts, so this we called AI/ML applications on DestinE Data Lake. So the key thing here was that we wanted companies to work in close proximity with an end user representative in order to make sure that what they develop actually can be used in a downstream application. So we had 3 of those. AI for Clouds is the first one. Fernando is going to present it in detail after me. This one was developed by Predictia in collaboration with Iberdrola as end user, and was meant to enhance the short-term forecast of clouds for the extreme digital twin. And then we had 2 examples of super resolution, so super resolution on MTG data. So all 3 contracts are near completion, and we plan to open source the model themselves and the source code and the documentation. We will probably discuss with ISA because it would be interesting to expose the models directly on the core service platform on their solution. Yeah, so this is an example that Fernando will explain, so how AI for Clouds works. So you start from the different data sources that are exposed on the data lake. So it's ERA5, ExtremeDT, MSG, Severi, and MTG-FCI. You do your data pre-processing, you do your model training, inference, you visualize, and then you serve all these results to the end users. And here you can see on the left-hand side that the different services that were used, not only from EUMETSAT, but also from ECMWF for working with ECMWF data, of course. So just to finish, this is an example of a workflow that we envisage on the data lake. So you have the data portfolio where you find, hopefully, your data sets of interest. You can access them either via the harmonized data access or via the cube in the future. You can use DFAIR, you can use EarthKit as well. We are actually discussing with ECMWF how to integrate DFAIR with EarthKit, so to bring the capabilities in EarthKit to read also our variety of satellite data. And then you can use our MLOps platform. So as I was saying, Kubeflow is going to become available pretty soon, and in the future MLflow and Airflow. If you have already access to your HPC resources, then so with the model that you have tested at low scale, let's say on one of our bridges, you can then go to an HPC, or you can make a request independent from DestinE for such resources. And then you get to your AI application. And if you produce also data or models that you consider are beneficial for the user community, you can contact us so that we can actually make that data available in the model. Yes, so this is all from my side. Fernando.
Hi everyone again. Now I'd like to share with you a work we are putting together, AI for Clouds. It's about enhancing short-term cloud fields for DestinE and how that can also impact and help the solar energy sector. It's going to be focused on AI tooling rather than talking about the system itself. And it's a work in collaboration between ourselves, Predictia, with SSIC. It's a contract managed by EUMETSAT. They also provide very helpful technical support. So in a nutshell, AI for Clouds, it's just an artificial intelligence solution that provides short-term up to 24-hour cloud fields for DestinE, and that it's been done by merging satellite clouds from EUMETSAT with EXtremeCity simulations. We've got 3 goals within this project. First is, of course, providing accurate cloud fields, then demonstrating its potential for the energy sector. For that, we are collaborating with Iberdrola as an end user. And finally, and a key goal of the work is building the system using DestinE's infrastructure and services. It's largely based on DestinE Data Lake, so we got a presentation before that actually is very helpful to later understand how we use the different services within DestinE Data Lake. But before we get to that, let me give you an overview of what AI for Cloud is, because then we can understand what we are doing here. So the first thing we had to think about when we started working on AI for Clouds was about how we can merge EXtremeCity with satellite clouds, because we have seen during yesterday that AI for EXtremeCity simulations are quite accurate, but still they have limitations. They've got systematic biases, but we know these simulations are deep convection permitting scales, and also we use only the first 24 hours of the simulation, so that really helps us limit the error growth of these simulations. So what we are doing with AI for Clouds, bearing this in mind, is using Anemone, a modeling framework that allows us to learn the mapping between EXtremeCity simulations, thermodynamics and dynamic fields with satellite cloud fields from EUMETSAT. So the system needs to learn the implicitly bias that have EXtremeCity to be able to make the inference and produce satellite-derived clouds. So the products we are providing with AI for Clouds are total cloud cover, cloud optical thickness, cloud top pressure, and cloud particle effective radius, all very important for the solar energy sector. The way we are doing, very briefly, we are approaching two different modeling methods. One is the direct one, in which we just take the extreme TT, thermodynamic and dynamic fields, and let the system learn the mapping throughout of the first 21st hours of the simulation. The second approach is complementing with conditioning with satellite clouds. So the way we do it is we take the last observed cloud states, and that provides the system enhanced contextual information, and that information is carried out throughout of the 24 hours of the system. So by doing this, we do an ensemble. It's performance-weighted ensemble mean of these two approaches. So we are happy to see and to present these results. This is the root mean square error of the 24 hours total cloud cover. So the lower, the better. And you see how the AI for Clouds in blue outperform consistently. This is just for one location, but it's, we have been checking different locations with Iberdrola. So it outperforms consistently not only IFS, but also ERA 5. So this was the main overview of AI for Clouds. We've got exciting results there. But I'd like to focus today on the operational overview of AI for Clouds. So this is the part that is seamless to end users, and the part that I like to discuss today. This other part, what the end users receive or they can play with, it's been covered somehow yesterday with a presentation and a demo we've been doing, building a viewer for DestinE Climate DT. So it's very similar. We'll provide a viewer for AI for Clouds. And we also will provide notebooks within the stacks in the DestinE data lake. But those are for end users. Let's focus on how AI for Clouds is implemented within the services. So in an operational way, we use Airflow, has been presented before. So we use Airflow as our workflow orchestrator, and we split in two different workflows. One is making the inference, which needs the data retrieval, some processing, and then serving the data to the users. And we have other workflow, which is actually validating consistently and keeping track of the performance of AI for Clouds in case, for some reason, the system starts degrading. So let's look into the details. This is the deployment overview. As I mentioned, it's based on Airflow with two different workflows, the inference and the validation. It's mainly working as a recipe. Like when you are cooking, it's a directed acyclic graph, so it's just following a recipe. What we do is first building the connection to the different components via reusable tasks. Then we build the environment for both the inference and the validation, and then we group them in different tasks. So before we even get to being able to run the workflows, we need to actually build the environment. So for that, as Miruna mentioned, it's very important to be able to reproduce what you are doing. So we are based on Docker. So the first thing we do is we build the environment from scratch, as you can see on the left. So you need GitLab credential. Then via a bash operator, you create your Docker file. Then it builds both the inference and validation environment. But this process is very time-consuming, very heavy. So we have another script in which it just checks the latest status of the repository and see whether you need to update any of the packages, of the over 200 packages that we need to have installed to run the system. So this way, on daily basis, we can be sure that the upstream repositories are downstream to our system. Then when we've got the environments, we can make the inference. As I mentioned, this is just a recipe. To make the inference, again, you just need your DestinE credentials, then we sync from the S3 bucket to the local virtual machine, and then just follow a recipe. Just download the data, interpolate the data, and harmonize the data largely using EarthKit. Once you've got your harmonized data in an AI-ready format, you do your inference, combine the inference following a performance-based approach, and then you do some plots and some processes to serve the data to the users. And to serve the data to the users, we move back the results to the S3 bucket of the DestinE data lake. So that's mainly the inference. This is about the data management. I just like you to focus on these two, because this part is the operational one. So we use the HDA service to retrieve both FCI and eXtremes TT, and then we try to use as much as possible existing tool. Particularly, we base our post-processing on EarthKit and Anemoy. So from EarthKit, we can do all the regridding and harmonization steps that we need to put satellites and simulations data set in a common format, and then using Anemoy, we can actually create a ready data sets. Both it's because I didn't say before, but for AI for Clouds, we are modeling the full Earth, but we are zooming in over the Iberian Peninsula, which is the interest of Iberdrola. And then, of course, we keep the track of how AI for Clouds is performing. So very similarly to the inference workflow we do for validation, we retrieve the data later on when we've got observations of clouds, and then we post-process the data and evaluate the previous inference of clouds with the available observed cloud. And if there are some degradation of the performance, which is a threshold, it's an arbitrary threshold, we get a notification that something is going wrong, and we have to see about what's going on, whether it's something about the system or it's something about any other issue, and think about whether the system needs to be retrained or what is the approach to take. So I think that's all from my side. Thank you.
Right. Thank you very much to all the speakers. Can I ask you, the organization, to place again the Slido QR codes there? We have collected already a few questions, and we'll now start the Q&A session. If I can have the questions there. All right. Right. I think, Miruna, you help me organize the...
Yeah.
I think you can take the first one.
Yes, so of course we are now discussing with Thiago and his team about the integration with EarthKit, but yes, the next natural step is to work with the Anemoy datasets. And it was a pity that we didn't have yet DeFair when Fernando was doing the work in AI for Clouds, but now we plan to have a continuation with him because he had to do by hand all the operations that DeFair is doing in order to be able to put our satellite data into Anemoy, because you've probably seen he's using Anemoy in his project.
Indeed. And the next question, can users tailor the model configuration in forecast in a box, i.e. spatial resolution? Since that part is actually part of the Anemoy inference, I'm going to pass that question to Harrison.
So if you saw Sarah's talk this morning, one of the cutting edge things that we're exploring with Anemoy is this idea of a multi-domain model, something that has been trained over various domains over Europe, particularly at the moment. For those sort of models, we expect to be able to change those graphs. Because the AIFS and the associated models are built off graph neural networks, there is no reason why we cannot simply just change that graph. So yes, the answer is soon. The cutting edge models will be able to be dynamically evaluated, dynamically moved over different regions, which is what we're exploring with the ArcX program, and part of that will be able to go to high resolutions. The exact skills of those is yet to be determined, but it's an interesting avenue of exploration at the moment.
Thank you. The next question, can you explain how the combination of the DestinE AI Hub and Delta Twin would work in practice if the models are deployed on Delta Twin? What does the AI Hub then allow the user to do? Who would like that?
Yes, thanks. So indeed, let's say that the AI Hub has more the idea to provide the user direct access to pre-trained model, and for this I answer also the other question, that is you cannot perturb initial condition in the AI endpoints, because these are pre-trained model for which you cannot intervene in the setup. But the other main point of the AI Hub is the possibility to have a library of models, so a shared knowledge of models that you can either review quickly on, I would say, minimum computing access directly on the AI Hub, while if you need to work deeply on that, you can take them out and use it, for example, on Delta Twin, on other services in the platform.
So next question, for AI for clouds, did you require HPC access, or were the resources in the data lake enough for your whole use case?
That was an important point of the work. So everything we've done was within DestinE Data Lake, and for that we used iLED compute and iLED storage. We developed the system using just a GPU with H100, which was good enough, and then we have some computing storage capacity for doing the job. But everything was done within DestinE Data Lake.
Okay. Maybe I'll go to the question on the bottom, since they're longer. Is it possible to perturb the initial conditions before running the AI models in AI Hub or Delta Twin?
Okay. I take for the AI Hub, as I said. In the endpoint part, no, because these are pre-trained. In the other, in the computing environment for the shared library, yes. So you can work a bit on the condition and on the model parameters, while for Delta Twin.
In Delta Twin, the builder can choose which kind of parameter he defines as input. So he has the choice to give when the component will be executed, to share some parameter or not. It's though about the license of the component.
Okay. Next question. For Anemoy's roadmap, I think this was more for Sarah on the previous session, but I think, Harrison, you're going to give it a go. For Anemoy's roadmap, do you plan to continue training and improving the model? And if so, what's the foreseen temporal resolution?
For this one, I think it's important to distinguish between Anemoy and the AIFS. Anemoy is the framework of which one of the possible outcomes is the AIFS. And other possible outcomes are what we've seen from the other meteorological services. It's what we've seen from the work of earlier from Fernando for the climate one. So if I answer it from the AIFS side of things there, we do plan to continue training and improving the model. We've just done our V2, and we're already well underway for training of the V3. It's going to be a long-supported work for eSIMWF. We're exploring adding new variables and increasing the resolution to match the IFS. We're still a lot more coarse spatially and vertically. And for the foreseen temporal horizon for the AIFS, we very much focus on that 15-day medium-range window. However, there are exciting applications of Anemoy for the climate. eSIMWF is working on the AIFS subs, which is a sub-seasonal targeting model, and there are other work being done for the climate, multi-year, decadal sort of predictions as well. I got a bunch of them, yay. Can it be used to deploy models that predict other features than climate, i.e. crop yield? Most definitely. Anemoy is building that framework for machine learning Earth system modeling. If you have the data, if you can model it, you can make an Anemoy model for it. So what we've seen with the curation and the preparation of data with the DEFAIR, that will hopefully make it a lot easier to be able to take those data sets, to prepare them, to get them into that Anemoy data set format, and then you can run that training. So most definitely, the limitation at the moment is simply what data do you have available?
Right, the last question, I'm not sure to whom it's aimed at. Are you documenting, tagging, and cataloging the AI model guardrails and inputs at any given time, and who monitors that repository and keeps it clean and consistent?
Yes. Yes, sure. Clearly, the API for sharing models and will require some, for example, mandatory fields that should be compiled by the users, and this will guide correct indexation and recording of the models. Then the user will be always capable of keep the models for themselves, but in order to share the models on the repository, they should follow this kind of guidelines and the API that manage all the consistency and correct information, I would say.
And I think we clear the questions. Since it's 5 minutes to 12 and we are out of questions, I'm going to give you 5 minutes extra for lunch. However, before we go to that, a few logistics information. Lunch is now at 12 outside until 1 o'clock. Please remember that there are some demo sessions happening here to the left, and after lunch we are going to resume at 1. There will be sessions upstairs, there will be sessions here. Make sure you look at the program to choose which ones you want to attend. There will be training sessions too in the afternoon. If you are registered for those, please go in and participate. And with that, you get 4 extra minutes for lunch. Thank you very much, everyone.